Okay, in question 7a, I've set up my parallelogram showing all the information which is being extracted from the question. I'm showing my ratios between key points. I'm showing the intersection point Q here, and I'm just clearly showing all the information that I've got from the question, which then lends me to part B, finding the ratio of C to Q to A. Now, this is a question where we need to aim to approach Q from two different directions, because we're going to be comparing coefficients. So what I'm going to do is I'm going to be thinking about going to Q from O to M, M to Q, and then O to Q from O to C, and C to Q. So those are my two different directions. So let's just have a look at what we've got here. So in the first case, there's the second case. So C to Q is some multiple of C to A. I know C to A is A minus C. Expand that out. Collect like terms. I've now got an expression for the vector O to Q with regards to K. On the right hand side here, I can look at O to Q going from O to M plus M to Q. So M to Q is some multiple of M to P. So I find out what the vector M to P is, expand that out, and I'm going to collect like terms. Like so. So I can now start comparing coefficients. So looking at the vector C, compare the coefficients there, and again this evaluates to k equals a half plus L over 2. Sorry, no, this is the evaluating for vector A. I've now got simultaneous equations. Let's just remove the fractions in each case. I can then set up, because I've got 2k minus 1 equals L, if I just double that, I can then equate it equal to this here. Then that evaluates to k equals 5 over 7. And substitute that back into my number 2 expression. And that gives me L is equal to 3 over 7. Okay, so originally we said C to Q is some multiple of C to A, and we've managed to evaluate for K. So K is 5 over 7, 5 over 7 C to A. Then Q to A must be 2/7 of C to A. Therefore, if we compare the ratio C to Q to A, we've got 5/7 over 2/7, which gives us a ratio of 5 to 2.